So there we go. So number 6, we got the truck colliding with a car. The problem tells you the mass of the truck is 1,360 kilograms. And the mass of the car is 1,100 kilograms. Now, it tells you that the car is traveling at 24 meters a second. So based on my arbitrary drawing of this, point for me, which way does the car have to be going? To the left, right? Because if they're having a head-on collision, the car has to be going this way. All right, so notice I'm drawing an arrow because it will help me process my positives and negatives. And I'm going to label this the velocity of the car initially. And I'm going to make it 24 meters a second. And then I'm going to consult the arrow that I just drew, and I'm going to realize that because the arrow points left, this velocity has to be negative style. Good? All right, so that is what it tells us. I know that the truck is moving this way initially. I do not, however, know how fast it is going. Is everybody good up to there? Anybody have any questions? We're good? Andrew, you good? Yep. Sarah, you good? Lily, you good? Yep. Cool. All right, now what else does it tell us? It says after the collision, the car continues forward. Point for me. After the collision, which way will the car be going?
Left.
Continues forward. It means it's still going the direction it was going before, so the car has to still be going this way. At 4 meters per second. What do I need to do since it's going that way?
Negative.
Make it negative. Is there anybody who is confused about why that has to be like that? Alrighty then. And then the truck rolls back at 6 meters per second.
It's like this section just like is assigned, right?
Yeah.
The really hard part.
Good? Questions, issues, concerns? All right, so to me, this is the hard part. Once you get this, it's just plug and chug, you know? All right, but let's run through it once, because I don't think we've actually done that, other than in the video. No. All right, so the whole premise behind conservation of momentum is this. Our total momentum before the collision must equal our total momentum after the collision. Please be careful. Total momentum before the collision means I want to look at all of the stuff before the collision. Right? Initial and initial. Don't make the mistake of doing initial plus final, because I've seen people make that mistake a few times. Okay? So all of that total initial momentum has got to equal our total final momentum. Cool? So that means that the mass of the truck times the velocity of the truck initially plus the mass of the car times the velocity of the car initially has got to equal the mass of the truck. Try again. Mass of the truck times velocity of the truck final plus the mass of the car, velocity of the car final. And plug in your numbers. So as a quick comment, this equation here, this is supposed to be a C, by the way. This equation is not on your equation sheet. But you guys understand where this giant equation comes from? It's just momentum is mass times velocity, right? So this is just momentum plus momentum equals momentum plus momentum. All the initials equal all the finals. Good? Questions, issues, concerns?
The EPI is, oh, that's not, that's just something.
What's something?
What equations that, is it just the equation for momentum that's not in the equation sheet? It's not like any of this.
This big long one is not on the equation sheet. P equals MV is on there for sure.
Oh.
Good, Meredith, you doing all right? GG? Everybody good? Zoe? E? Ethan E?
Oh, yeah.
You good?
Yeah.
Cool. Anybody ever put an E at the end of your name like that?
No.
Well, now you can't say that.
Just short.
You just ruined a good thing.
Just short the E.
Oh, just E. Oh, Ethan. Oh, I see.
Mm-hmm.
Gotcha. Dustin.
Oh, wait, this was on the equation.
What?
I didn't know.
The long one is on there. Ooh. All right. Not for long.
What?
That's fine. No, I'll leave it on, but I'm taking it off next year. Damn it. Because I'd rather have you understand it than just pull it off of a random equation sheet. All right, so are we good?
Can I tell you a quick funny story?
Yes.
So I was making a safety exam last year, and I made a ton of awkward misspellings, right?
Mhm.
And so I said, I'll
Awkward,
do it next
like-
year. Like funny, like bare hands instead of
Gotcha,
bare
bare
hands.
hands.
And so this year, I accidentally printed off the wrong one, and I printed like 80 copies, and so we had the same bad exam because I forgot.
I have done that many times myself. All right, so let's plug in our numbers. So here we go. It's literally just plug and chug. Mass of the truck, 1360. Velocity of the truck initially, that's what we're looking for. Mass of car, velocity of car. Don't forget that negative sign. Mass of truck, velocity of truck. Don't forget the negative. Mass of car, velocity of car. Don't forget the negative sign. Cool, you guys? And then solve it. Any problems? Yeah, Andrew?
I have a question about like the test. So because there's so many problems that I kind of plug and chug, I can have a lot of conceptual stuff on.
Yeah, so I was going to talk about this a little tomorrow, but my tentative plan for the test is 2 conservation problems, 2 EFT equals M delta V ones, from 8-1, and then some like concept E, short answer E, multiple choice E, fill in the blank E, true false E type things. So
Is it going to be like one front, just one page front of
I spread it out a little bit more just because the multiple choice takes space just to type them. Do you know what I mean? So I think it's going to be 3 pages, but. And did I tell you guys this already that I was planning on counting it less than a regular test? I was thinking 30 points instead of 40. Okay. But I know some people struggled with that last test and want the extra points to bump their grade up, so that's part of the reason I was planning on jamming it in onto this term. Yeah.
Okay. Would you, sorry. Okay. So remember how, more than on this work, I think it was an 8.1, and the problem, at the end was, explain, using, explain what happened, using the words, impulse.
Yeah.
Stuff like that. Would you consider that, a concept problem?
Yeah, anything where you're solving it but not probably using a calculator would be concept-y.
Okay. And that's, a conservation of something.
The one you're talking about was impulse and momentum.
Oh, yeah. But, this is, just, whole worksheet, 8.2.
What about it?
That's just, okay.
Conservation of momentum, yeah.
Okay.
All right, everybody good? Do I need to go through the algebra behind solving this?
No.
Okay, so then, so you solve this and you find that the velocity of the truck initially is, 10.2 meters a second, if I remember right?
10, oh yeah.
Is that right? After you solve it? Okay, notice this comes out positive, which is good because that's telling us that the car was moving this way before the collision, just like we thought it would be, right? Cool? Any problems with that? Andrew, you're good? I think we're one of the people who mentioned this one,
Yeah,
yeah?
I just had a sign error.
Sign error, okay. All right, is everybody, yeah, so.
So if you did it the opposite way, then the velocity would be negative.
Yeah, absolutely, and that's totally fine.
And then with the momentum would be positive.
Correct. Yes, that's true. Yep. Yeah. So all of your signs would just be flip-flopped from mine if you had your drawing backwards, and that's totally okay. All right. So now parts B through I sort of ask you to further analyze this. So B and C ask you to find the total momentum before the collision, and C asks you to find the total momentum after the collision. So look, you guys, you've already kind of done the work. Total momentum before the collision, that's this mess, right? Okay. Total momentum after the collision, that's this mess. And they should be equal, right? Which is why both answers were negative 12,560. If it doesn't work out exact, that's just because this velocity is rounded. Cool? Yeah?
Okay, so on a task, is there what would you say the biggest difference between okay, sorry. You know there's a small rounding error, they're not exactly the same but they're close. What would you say is the maximum they can be?
I would say that your first 3 digits should be the same, and after that it might fall apart a little bit. You know what I mean?
Yeah, but if you continually use the x for each one, your answer could be 2 whole decimal, 2 number points off. That's
That's why I tried really hard to not round until the very, very end.
Oh, so if you have the right word, please go here.
If you're worried about it, don't, round, give me a few more numbers after the decimal. Okay. All right, so is everybody good up through part C? All right, how do you find the change in momentum for the two objects, you guys? Final minus initial, right? So to find your change in momentum, you can either find the final momentum of the thing, find the initial momentum of the thing, and then subtract, or you can do this, which amounts to the same thing. Good? What should be true about the change in momentum for the truck and the change in momentum for the car? Sort of.
Oh, magnitude-wise, they're the same, but they're different signs.
Good. Why? Why do the signs have to be different?
Because they're going in like opposite directions.
Yeah. So one of them's negative. What's that telling you? One of your changes is going to be negative, which means you... not necessarily.
Oh, okay, I guess.
What do you got? Oh, somebody. Willis, is that you? Somebody. No? All right. AJ, what do you got?
No, why don't maybe I can.
I just said like you lose.
Yeah, that's what I was looking for. Yeah, if your change in momentum is negative, you lose momentum, right? So in this problem, I think the truck, the way I have it set up, the truck loses momentum. Where'd it go? To the car. So the change in momentum for the truck should be negative, change in momentum for the car should be positive, or vice versa. Maybe I have the signs flip-flopped. But the point is, one of them has to be negative and one of them has to be positive. Cool? You good or no?
Oh yeah, I'm good.
All right. Any problems then, you guys?
Would you mind just going over G, H, and I?
G, H, and I? Yeah. Okay, so let me talk. So there were a bunch of questions throughout the worksheet that said, was this collision elastic? If not, how would you describe it? All right, so we talked about three types of collisions, right? Completely inelastic, and elastic, right? Which one of those three should be the easiest to identify?
Elastic.
Completely
Wait, no,
inelastic.
completely inelastic.
Completely inelastic, right? It's easy to identify completely inelastic because the objects stick together, which means that both objects are going to have the same
Final velocity.
final velocity. Okay, so if you're reading the problem or you solve the problem and you discover that your two final velocities are the same, automatically it's completely inelastic. Bless you. Good? If not, if they don't stick together, if they don't have the same final velocity, then you have to find your total kinetic energy before the collision, your total kinetic energy after the collision, and compare them. Okay? If they are the same, then it's elastic, and if not, then it's inelastic. Cool? Yeah?
This is a little off topic. We gotta try to check them out.
All right, let me come back to that. Everybody okay with the whole elastic versus inelastic thing? All right, so to answer your question then, so for part G, Ethan, So we had just figured out our final velocity. So at this point, we know all of our velocities, right? So I can find my total kinetic energy before the collision by finding the kinetic energy of the truck, kinetic energy of the car, and adding them, right? And I'm going to get some big number. Do I need to run through that calculation? Anybody? All right. Similarly, I can go through and find the total kinetic energy after the collision, right? And see if they're equal. Good? If they are equal, then, oh, it's elastic. If not, it's inelastic. Cool? Sometimes you can take a super secret ninja shortcut. I can tell you this one is inelastic without doing the math. Anybody see how? What's going to happen to the kinetic energy of the truck? Is it going to increase or decrease?
Going to
One Baldwin's please.
Yeah, look, the truck is going from a speed of 10 to a speed of 6. It's slowing down. Remember, the signs don't matter because it's 1/2 mv squared. Right? So you don't have to worry about your signs. So the idea is the truck is going to lose kinetic energy because it slowed down. Oh, the car is going to lose kinetic energy because it slowed down. If both objects lose kinetic energy, then we must have lost energy. So it's got to be inelastic, right? Okay, so if there's a problem like that on the test, if you want to just write both objects slow down, so we lost kinetic energy, it must be inelastic. That's cool.
So where did the energy like go?
Sound, heat, deforming the cars,
Okay.
like the energy required to bend the metal of the cars. Okay?
So do we ever have a completely
In the
elastic?
real world, no. In the real world, no. 'Cause
So then why do we want to do math with if it doesn't apply to the real world? You know what I mean?
acceleration of gravity is not really 9.8, but do you want to solve them with air resistance?
No, that's not yet.
Okay, you know what I mean?
Yeah.
So, yeah, so
I was gonna say, so like, if it was elastic, the velocities wouldn't change from initial time?
no, the velocities could change, but you'd have to have one of them slowing down, one of them speeding up, and then you'd have to do the math and figure out what happened. Do you know what I mean? So. Questions, you guys? Yeah?
So what about for G and H?
Those are the ones I just, G is finding the total, Kinetic
I
energy.
misread it. I accidentally read it as total force or something like that.
Gotcha,
Not
yeah.
energy.
So you good then? Yeah, you just do 1/2 mv squared plus 1/2 mv squared,
Yep.
and then same thing here for
Yeah,
H.
I did it for all the other ones, just
Gotcha.
because I misread that one.
Yeah,
So for the one where they stick together, they're gonna have like the same change, right? Is that what you said?
well, they'll always have the same change.
Yeah. So would their final velocities be the same then? And is that one way you can tell? Or would it
Their final velocity is the same because they stick together.
yeah. So that's if you want to say like the final velocities are the same, therefore
Therefore what?
it's elastic.
Completely
Completely
inelastic.
elastic.
Yeah. Good. Eva, was that hand up? No?
Oh, no.
Anything else, you guys? Alrighty then. Okay, so my first hour, literally nobody had any questions on this. So I stared at them awkwardly for about 5 minutes and waited for somebody to ask a question, and nobody did. And I said, okay, great, go ahead and get started on E2B. Almost everybody finished E2B, which means I have nothing to do with them tomorrow in class. So I asked them if they wanted a target check. So here's the deal. I can give you a target check, but you'd have to grade them on your own. You know what I mean? It wouldn't make sense for me to give you a target check and then give it back to you the same day as the test. You know what I mean? So if you guys would like, if you guys use the, what have we still got like almost a half an hour, right? So you guys ought to be able to use the next half an hour to work on, you know, the A2B stuff. And tomorrow I can go over and answer any questions you guys have got. And then if you guys want, I can throw together like a little review, target checky style thing and give you guys part of the hour to work on it tomorrow and then just go over it during class. Is that something you guys want? You guys want more practice? Yes? Concept-y stuff? Yeah, that's what I think people probably want to practice with. Sure, I can do that. Because I feel like the math stuff this section is easy. It's the concept-y stuff that people tend to struggle with. Sound good? All right, so I will have that available for you tomorrow. Cool? This is totally weirding me out having to do these.
Why? It's strange.
So I'm like going the opposite of cross-eyed. Yes.
Okay. So I have a question for number 2, and I figured out number 1. Like, don't ignore this.
All right.
For number 2,
I'll drop everything for your
Did you figure out A?
for A, no, that's all the stuff.
Gotcha. Hey guys, real quick,